Hello friends, this video on electrochemistry part 32 is brought to you by examfear.com. No more fear from exam. Battery is dry cell, which we use in our life. The mechanism is almost similar to Leclanche cell, but it is little compact. If you see the Leclanche cell, we have this MnO2 here. Here we had this carbon, here we had this zinc, and here we had this NH4Cl. Correct? Same thing, this MnO2 here we have, this carbon will have here, right? The whole body will be of zinc and will have this is as nothing but NH4Cl. The gray one here is NH4Cl. So we have the same component. If you see, we have, but the setup is a little different. Here we have also the porous spot we have. Everything is same, right? It has zinc container, the whole container, and zinc container itself will act as anode here. This will have a negative charge and this will have a positive charge. So this zinc container itself here will get a negative charge because this zinc itself is a negative charge, right? Here we had this is negative, this is positive. Same thing here. If you see, carbon gets a positive charge, zinc gets negative charge, right? And here also we use carbon rod, that's a graphite rod actually. And this is again MnO2 and carbon, again acting as anti-polarizing agent, right? And this space is filled with a moist paste of ammonium chloride and little bit of zinc chloride also, NH4Cl and ZnCl2 paste. Anyway, ZnCl2 will be forming, right? The moment the reaction happens, we'll see that ZnCl2 is formed. So that will come, even if you don't keep it, put it, it will come in due course of time, right? Here my NH4Cl is the electrolyte. Again, carbon and zinc is my electrode, similar to this. Same reaction, NH4Cl is a strong electrolyte. It becomes NH4 plus and Cl minus. This Cl minus, so I have NH4 plus and Cl minus. This Cl minus will react with zinc, right? Its Cl minus will react with zinc to form ZnCl2 and 2 electrons. Oxidation is happening, right? So with this, zinc gets negative charge, lot of electrons here. So once you connect with this circuit, the electron flows from here to here. Carbon also gets electron. Now carbon has got the electron now from the circuit, external circuit. This NH4 which we have got here in this NH4 will react with this carbon because it has electron to give NH3 plus hydrogen gas, and this hydrogen gas will be now used by this polarizer, this MnO2, to form water and Mn2O3. Correct? So that is a very simple reaction, and for this the potential is 1.5 volt. Now since it has paste, actually it has paste here. Now if you see, we are talking about NH4Cl and NH4Cl paste. Since there is paste, it is not an aqueous solution, it is a paste. Thus if you see, the concentration is almost 1 molar. Correct? Thus since the concentration is 1, the voltage will not drop. As per an honest equation we have seen, right? E is equal to E naught minus 2.303 n RT by NF ln of Q, right? So this will also become 1. So this whole thing will become 0. So the voltage will not drop because Q is nothing but the concentration of, the whole solution you would take, concentration of product by reactant. Since this is in paste form, the concentration is almost 1, so the voltage will not drop for this kind of cells. Almost always 1.5 volt. So next type of cell we'll learn is the Mercury cell. They are very small in size, and they're usually used in the device like hearing aids. They're used in the watches or sometimes in toys also. They're very small cells. They are very low current device, They are mercury cells, generally used in watch. So if you see, this part is my anode, the yellow part is my cathode, and the green is a separator. Right? So for anode, actually my zinc and mercury amalgam is used for anode. For cathode, HgO and carbon is used for cathode. And electrolyte here is my KOH and ZNO paste. That is my electrolyte. Correct. So if you see the reaction at anode, I have zinc and mercury amalgam, right? So you take this Zn Hg amalgam, actually it react with HgO, that is solid, to bring ZnO plus Hg. There's something wrong here. See, at anode, what will happen? Oxidation will happen. So there is zinc, it will get oxidized to Zn plus 2, right? So let me write the reaction. So I have zinc in amalgam form. Let's suppose zinc solid. It will become Zn plus 2, right? How it will become? It will take some 2OH minus from the paste, because the paste has some OH minus, correct? It will become ZnOH2 and it will give 2 electrons. So if you see, this is nothing but zinc with the zero charge, zinc with a positive charge. There is oxidation happen. If we talk about reduction, and that will happen at cathode, yellow area. So my HgO I have used here, so it will react with water that is also in the paste, and it will take 2 electrons. It will form Hg in the liquid form and 2OH minus. It will go back to the paste, and the same 2OH minus will be used here, correct? So if you see the overall reaction, if you add these two reactions, see the overall reaction, I have zinc that is in solid state. When it reacts with HgO, that is also solid, it makes zinc oxide, that is also solid, plus Hg, that is in liquid. And if you see, there is no ion in the solution, right? It's all the paste form, and it has a voltage of almost 1.35 volt, and this can be used for a longer period of time. I hope you understand the reaction. Zinc is oxidized to Zn plus 2 at anode, and cathode, Hg plus 2 is reduced to Hg. The next. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.